discharge pressure transducer, we got that guy set up. Yes, we got discharge pressure, discharge temp. I'm just going to click the arrows to kind of clean up the screen a bit. Suction temp, and we got our suction pressures. Outputs, we'll just do a couple compressors. We'll get to that. Sorry, we'll get the compressors in a minute. Group LSV. Group LSV being if you would have a defrost differential valve or some sort of solenoid or valve that requires a relay to energize or de-energize. In this case, being plus 20, we'll assume we have no hot gas or cool gas. We'll assume everything's electric. It spits out a couple values we have already. We'll revisit that shortly. Stage setup. Chose 3 compressors. Let's say, I don't know, let's pick the first one's going to be on a frequency drive. It'll be 7.5. In this case, I'll assume this is horsepower. 15 and 15. Compressor proof. Yeah, let's assume these compressors have compressor proofs. Being I don't know, the non-frequency drive, you can do current sensing relay, and get fancy in a frequency drive, you can use one of the relays on the frequency drive to show proof of running. Stage out. Stage out being where are we going to control what relays are going to command the compressors to turn on. What I'm going to do, we have one 8RO board that we previously configured. I'm going to select 8RO number 1. I configure this. I'll just leave that as it is for the sake of saving time. Relay number 1 is for compressor or stage number 1. Stage number 2, we'll quickly configure this. Assume stage number 2 is relay number 2. Stage number 3 will be relay number 3. We have to drop down on that. Is anything else we really need in here? Not really. You can get into some fancy stuff, but in this case, we'll kind of keep it simple. Variable capacity. We have the variable capacity tab because when we configured our stages, we chose a variable speed compressor for our lead compressor. In this case, variable speed alarm. So example being frequency drive goes into some sort of fault, a relay would close in the drive that would go to an input to show that the drive is in a fault. Let's make one up here. 16 AI number 1. I'll put that in my last digital point. 12. I'll probably forget what point I have that on, so I'm just going to make note of that. 12. It's going to be digital, being on off. Sure, let's save that. Max speed, we'll assume this compressor is only going to run 1800 RPM. Increase rate, let's just leave the default stuff. Usually all this stuff just kind of tweak it and tune it depending on what your compressor application is with the drive and all that stuff. Inverter reset, being if your frequency drive has an input that allows an external reset. Variable speed alarm out if you want a specific relay alarm, relay associated to an alarm specific to that compressor. Variable speed stage out, in this case, this is the analog output. Let's choose analog input 1. Sure. Just use the default stuff. In my my trainer that I have the E3 in, I have 2 bar graphs that display 0 to 10 volts. So it's kind of handy for the sake of kind of testing stuff. That would be it for the variable speed. Going on to the next tab, alarms. Yeah, default is probably good for most applications. Usually if your suction group gets an alarm, it's safe to say it's critical alarm. for alarming for future, kind of touch on it now. You can filter alarm output rather, based on critical, non-critical, and what user and all that other stuff. You can kind of filter out who gets what. Proof alarms, or sorry, proof inputs. Let's do a couple quick proofs. If you want me to go over something a little slower, let me know. Some of this stuff I'm just kind of going a little quicker through. In this case, we're going to assume board 1.9 is going to be our comp number 1 proof input. Yeah, I'll assume, I'll do these fast, I guess, just for the sake of doing it. Compressor proof 2, I'll just kind of quickly throw this in as well, just so we can use up all those digital inputs. Yeah, it's nice to have more characters. You can just kind of have a legit kind of name to it instead of half guessing.
Oh, it makes it so much cleaner and easier to troubleshoot when you're not like having to try to figure out what somebody made an abbreviation to, and you got guys asking what the hell this abbreviation means.
Oh, exactly. Like, especially when you get into like descriptions of flexible combiners, you can have a lot of characters to it, which is quite nice.
See, that would be killer right there, because that's where it gets the worst.
It'd be killer if they actually put definitions on there instead of just leaving it freaking blank.
Yeah. That's a whole separate conversation.
That makes you want to punch kittens. Like it hurts so bad.
Like half CO2 racks out there that certain people program.
Yeah, I hear you.
The ones that you program, Kev?
I'm not a jerk. I put descriptions. You know the people who are truly evil are the people that don't name inputs.
I agree. Yeah. That's